Greetings, math fans. All right, so this is our second day of logarithms, or as we like to say, logs. All right, so I'm going to show you kind of first of all, a little more difficult way to do something, and then I'll show you actually an easier way to do it. Okay, so I just want to explain what's going on here. So if I give you guys a problem like this, log base 2 of 8. All right. So what I had you guys do in the past, which is yesterday, is I set it equal to x, and then you wrote this an exponential, 2 to the x power, right? Right. This to this power equals 8. And then I had you say, well, what is 8? You got to have a base, which is the same as this. So this is 2, and 8 is 2 to the what power? It's 2 to the third power. All right, so you had 2 to the x equals 2 to the third, and then once you have these are the same, then my answer is just x equals 3. Okay, so that's not bad, right? That's pretty easy. I have a nicer way to show you. All right, this is an awesome way to do it. So let's actually take a look at just a different way. Let's do, again, log base 2 of 8. So this is called change of base. So here's the deal, math fans. This is a base 2. Okay, we don't have base 2 on our calculator. In fact, if you look at your calculator, all right, there's a nice little log button, of course, on your calculator. Okay, and so kind of just look down a little bit, and you'll see it's on the left-hand side on your TI-30 X2S. Okay, you got to look for the log button. But that is really only a log base 10. We have a log base 2. So you can't use this thing directly. You can't just type in log base 2 of 8. Just can't do that. So what we're going to do is we're going to do something called change of base. So it's really simple what's going to happen here. Okay. So the first thing I'm going to do is it's literally log of 8 divided by log of 2. Now this is log base 10, which again you don't really need to worry about, but now you're going to use your calculator. That's how easy this problem is. So you're going to divide so we'll even get rid of that 10 because it's just they're all 10s for what we're concerned with. So log of 8 divided by log of 2. Just type in your calculator. Okay, now be careful because it gives you a parenthesis. So make sure you close the parenthesis before you hit divide. So truly, and it's a parenthesis here too. So truly what you have is log parentheses 8 divided by log parentheses 2. That's all you do. Okay? And if you do that, you get 3. Oh, it's like, what? That's so easy. That's all you do. It's pretty easy stuff, guys. So let me just give you a couple more here. If I said log base 2 of, let's go with 16. Okay, so think about, well, again, I'm not going to do it the difficult way anymore. We're just going to literally go log of 16 over log of 2. That's all you do. And the answer is 4. So if I give you guys a general term here, which I think is kind of nice, if I say log base A of B. Okay, so it can be any base. You would rewrite this as log of B divided by log of A. That's all you do. It's like super easy, guys. Okay, so let's just do a couple more just for practice. You know, practice on your calculator. So if I said log base 5 of 1 over 25. Okay, so you're going to type in log parentheses 1 divided by 25. So you don't need the fraction button. Just type in 1 divided by 25. That's what a fraction is. Just division, really. Divided by log of 5. Okay? And if you do that, you get negative 2. It's like super easy to do this, guys. Okay? Here, log base 4 of 1. Okay, so it's going to be log of 1 divided by, I'm going to put parenthesis there, log of 4. That's all you do. Okay, and that actually comes out to be 0. Okay, so that's how you deal. These are like the first 8 problems in your worksheet. Literally, it's just change a base. Okay, it's like super easy. Okay, so let's do one more. Okay, how about log of log base? Let's do 16 of 4. Okay, so again, that's going to be log of 4 divided by log of 16. Okay, and that's going to be, you're going to get 0.5. So I don't care if you put 0.5 or 1/2, just as long as you understand that that's the same thing. Okay, cool. It's pretty easy. All right, so that's like the first part. The second part is solving for x. So we've kind of done a little bit of this already, math fans, solving for x. So let's do, if I could, I'm just looking at the worksheet from last night. We had to solve for x. So let's kind of just review that a little bit, okay? We have there are basically 3 cases. Okay, the first case is going to be this. So case number 1 is if I have log, so you know what I'm going to do, I'll show them all here. So case 1, case 2, and case 3. So it all depends on where the x is. So the first case is going to be log base 6 of 36 equals x. Okay? That's what we just did, guys. Okay? We just did that. Let me curse this up here. But we just did this. So you're going to basically use change of base. So you're going to say log of 36 divided by log of 6. And your answer is going to be 2. Okay, super easy. So again, we just did that. Okay, the second case is we're going to say, and this is actually a really easy case here. So log base 4 of x is equal to 3. So this one you have to remember how to write it as an exponential. It's going to be 4, that 4 to the 3rd power equals x. Okay, you got to remember that this is from yesterday. So 4 to the 3rd power equals x, and then you got to solve for x. So x is equal to 4 to the 3rd power. You put it in your calculator, and you get 64. Okay? So notice where the x is. So I'm going to actually highlight this. Okay? Here the x is right after everything. It's not even part of the log. Here it's what you're taking the log of. And the very last problem is going to be where the base is the variable. So we're going to say log base x of, let's go with 16, is equal to 4. Okay, so now we're going to say x, right, again, right, we're using, put an exponential, x to the 4th power equals 16. Okay, and then you got to use that nice little friendly key if you got to look for it, guys. And we've talked about this, but it's basically your square root or your cube root or your 4th root. So it's got like this x, and then basically you put a value in there. Okay, so I'm taking the 4th root. This is really what I'm doing here, guys. I'm taking the 4th root of 16. So if you do that, you get x is equal to 2. Okay, so again, you're going to do the fourth root of x to the 4th is just x, and the 4th root of 16 is 2. Now, most of the time, if you do this, it would be plus or minus. But what you guys need to understand is there is no plus or minus when you have a base. Okay, in fact, you get this number here. So let me actually let me write it out in red here. If I had log a of b equals c, these two values must be positive. This one can be negative. But those two values, that A and that B, can never, ever, ever be negative. They have to be positive. Okay? For the last number, that can be negative. Okay? So anyway, those are our three cases, though. This first case here, guys, this first case here is really easy. This is change of base. This one's actually pretty easy, too, because you're literally just saying 4 cubed, right? It's really easy. And this one's a little bit more challenging because you have to take the 4th root or the cube root. Okay, I really think case 3 is probably the most difficult. So let's do a couple more case 3s just for practice. Okay, so if I said log base x of 3 equals 1/2. So you're going to write this as an exponential. X to the 1/2 power equals 3. And how do you solve for x? Well, you got to square both sides. That's how you get rid of 1/2. You got to square both sides. So x is equal to 9. Okay, it's not too bad. How about log base x of let's go with 27 is equal to 3. Okay, so we're going to say x to the 3rd power equals 27. So we're going to take the cube root of x cubed, which is just x, and the cube root of 27. So again, put in your calculator, the cube root of 27. It's easy to put in your calculator, guys. You got to use that XY button. Okay, if you don't know how to use it, learn how to use it, ask me, figure it out, but it's really not difficult. Okay, and then with the cube root of 27, x is equal to 3. Okay, so again, lots of different cases on how to do these, but I showed you all 3 of the cases, and make sure you know how to do all 3 of them. All right, so the next thing is actually just literally asking you what is the log of something. So we're going to call this common log. Okay, and common log is just using the log button. It's log base 10. This is the one on your calculator. Okay, log base 10. Okay, so if I give you a question, and so let's do a couple problems here, and everything's going to be rounded. So you're going to round everything to, for most of the time, I'm going to ask you to round to the nearest 4 places. So let's do a problem here. So if I do log of 12, it's like super easy, guys. You're going to type in log, but make sure you hit parentheses, right, and close the parentheses. So I'm going to do it on my calculator right now. Log of 12, close parentheses, hit enter, and I get 1.07918. And if I ask you around to 4 places, okay, so we're going to go 1, 2, 3, 4. So you look at this guy right here. Okay, that's 8. So the answer is 1.0792. Okay, it's like super easy. I mean, you can't do anything wrong. If this is common log, you literally put it in your calculator and get your answer. So let me just do a couple more here, but it's really easy. So if I said log of, let's see, 60169. That's the zip code for Hoffman Estates. Okay, so I'm going to type it in. Log of 60169, close parenthesis, hit enter. I get 4.77937, so that rounds to 4.7794. Okay, really pretty easy. Let's do one more here. Log of 0.8325. Okay, just kind of a random number. Okay, so again, type in log of 0.8325. Close parenthesis, and we got negative 0.0791615. All right, so if I round it to the nearest 4 places, it's going to be negative 0.07996, right? Because that's a 1 here. Okay, that's our answer. So this is a common log. That's all it is. So that's like, you have 6 questions on your homework like this. Okay, it's so easy. All right, so now we're going to do common anti-log. That's kind of scary. It's like against logs. It's very sad. So common anti-log. Common anti-log. Okay, so you're going to basically, you know that log button you see in your calculator? You're going to hit second log. That's what the common anti-log is. Second log, which is really 10 to the x power. That's what the opposite of log base 10 is 10 to the x power. Remember when I first taught you guys exponential versus log? I just said that they're opposites. Log is opposite of an exponent, okay? And that's what it is. You hit second log, that gives you 10 to the x. So the first problem is going to be anti-log of, so you'd say anti-log of 3. So literally you're going to type in second log of 3. So I'm going to do my calculator, second log of 3. Enter, I get 1,000. It's like super easy. Okay, so I do anti-log of 0.0792. So I'm going to do anti-log, second log of, so second log of 0.0792. Put in my calculator, 0.0792, and I get 1.20005. So 1, 2, 3, 4. So it's actually 1.2001. Okay? That's what anti-log is. It's just opposite. It's like really, again, it's super easy. Just type in your calculator. But make sure you hit second log if I'm asking for anti-log. Okay? So real quickly, one more thing I want to show you guys. If I give you a problem that looks like this, log of n is equal to 1.75. So in order to solve for n, I need to get rid of the log. So I take the anti-log of both sides of the log of n. And I take the anti-log of 1.75. So I just take the anti-log of both sides. That gets rid of the log. So you have n equals, and the anti-log, so I'm going to hit second log of 1.75, close parenthesis, I get 56.23413. So 56.2341. Okay? And I think sometimes they ask you to round to 2 places. So if that was 2 places, it would be 56.23. Okay. So the rest of them, again, if it just says, hey, if it says log of, 1.792, you just take the log of that. So again, I'm going to type this, if I'm solving for it, I have to solve for it and get rid of the log, then I do anti-log. But if I just say, hey, what is the log of 1.792? Okay, I would get 0.23 or 253338. So 0.2533. That would be my answer. Okay? So that's basically logs, anti-logs. We did change of base, and we learned how to solve, no matter where that variable is, we learned how to solve for the log problem. Okay? So that's it, math fans. Hopefully you guys are good to go with logs, and maybe someday you'll build a log cabin and you'll know how to work with logs. Have an outstanding day. Adios, math fans. Goodbye.